Mine, my apologies. I rushed to do this. I had an online session with my project and was up doing some things. No excuse, but I was getting ready to rake you guys over the cold. But we've not had this problem with people not showing up. So my apologies. We'll go ahead and start. I'm going to introduce Scott Fagen, very good friend of mine, very good friend of mine, very good friend of our programs, and has always been very instrumental. I've got a glare here. Let me address this glare. There we go. Very good friend of our program. Scott is probably one of the luminaries in his area in mainframe. He'll tell you about himself. I hope you have reviewed both his LinkedIn profile and his company's website. He informs me that he hadn't seen any notifications about people viewing his LinkedIn site. So just remember, in the IT space, there's a way that people can always tell whether you've done what you're supposed to do. So keep that in mind. But he'll bring you up to speed. So we're behind schedule, and I'm not going to keep Scott over. So without any further ado, I want to introduce to you my good friend Scott Fagen.
Afternoon, everybody. Thanks for joining. Cam asked me to, I should say, Dr. Say, asked me to join you guys and talk a little bit about my being in IT and my career. So I've been in IT professionally now for, let's see, 86, 82, 35 years, a long time. I've been working as a programmer since 1982. I actually started while I actually got a job. My first job before I started college. I was not coming from the most wealthy of families, so I actually qualified for a fellowship with the federal government in 1982, working as a Fortran programmer for the National Weather Service, the National Oceanic and Atmospheric Administration, which led me to actually taking an engineering course in college, where I graduated with a bachelor's degree in engineering, mostly around electrical engineering. And in 1986, when none of you guys were born yet, except for Cameron here, there was not a whole lot going on in the defense industry, and that's where most electrical engineers were going. But because I had been programming for both the federal government, I actually picked up contract jobs for some of the financial institutions in New York. I went to school at the Stevens Institute of Technology in northern New Jersey. So my dorm room overlooked the Twin Towers and the Empire State Building, just the reverse view that everybody did. I was working at a couple of the financial companies that no longer exist as a contract programmer writing in PL1 and COBOL. So from there, I was offered a couple of jobs in the electrical engineering defense industry, mostly with companies that don't exist anymore, like McDonnell Douglas and Faircott. And I think the only one that still exists is Northrop Grumman, but they are not the company that they were 33 years ago. And I took the lowest paying offer that I was given, which was actually the IBM Corporation. They offered $27,000, actually, bad money. So from there, I moved from northern New Jersey to Poughkeepsie, New York, and spent the next 22 years working on ZOS. I should say MVS, then OS390, then ZOS, where I learned a whole lot about a lot. Certainly a lot about programming, a lot about working with people, a lot about working with customers and what customers expect, a lot about architecture, and a lot about working within constraints, because I think most people will tell you after a while that working in the IT industry is always about working with constraints. You can never, at IBM we used to say, you could never get it right, but you can always do it over.
I hadn't heard that one. Yeah, Scott has a lot of these little tidbits. Yeah.
So in many ways, it was quite the education, because I was thrown into a product which had actually started being coded before I was born. Right. So the operating system that's modernly called ZOS which was called, the part that I was working on was called MVS at the time. They had started coding that in the late 1963, early 1964. I was born in 1964. And some of the code that I was working on was literally as old as I was. I mean, literally, there were comments that had years in them, and the years were 64, 65, 66. So it was quite an adventure to try to figure out what people were doing. To kind of give you some context, in the early 1960s, there was no such thing as a computer science degree. As a matter of fact, there was no such thing as computer science, right? There was data processing, and there was math, and there were algorithms, but there really wasn't much in the way of anything that was really formally called computer science. So most of the people who worked on writing programs were mostly mathematicians and, believe it or not, music majors, because there's a lot of commonality between the concepts in music and the concepts in math and computer science. So it was quite interesting. So when I started in Poughkeepsie, the man who was basically ran all of MVS development was a guy named Dick Butler, who I would work with off and on for the next 20 years. But he actually started at IBM working on the loading dock. He was a professional musician, and he went from being, a guy who was moving hardware around the factory floor to the guy who ran the entire place. So it was at different times than today. There'd be no way that somebody would be able to, kind of go into IT as a non-IT person and then, get to the top of the pile. That's just not possible anymore. But what he was very smart, and he listened, and he understood, and he was able to make fast decisions and make reasonably good ones. And that's I think was really the hallmark of his career, was being able to, kind of cut through the nonsense and be able to get people together to do the right things. Because it's hard to organize, the activities of 1,500 to 2,000 people in any kind of meaningful way. And to be able to deliver products on time and to work with a whole group of people, another 1,500 or 2,000 people who are in California, another 1,500 or 2,000 people who are in Phoenix or Tucson, and another 500 or so that were in Germany. And and over time, this number grew and shrank. But it really points out that some of the key factors in being successful in IT, whether you're on the development side or the product management side, or even the people management side, is you've got to be able to communicate with people. You have to be able to use your verbal word, you have to be able to use your written word, and you have to be able to share the rationale with people. And there's something else I think I talked to Dr. Say about, which is there's a difference in my mind between someone who's a coder, someone who's a developer, and someone who's an architect. Right? We all, if you go into this as you're learning how to code, you want to go into IT to become a programmer, you always have to start with being a coder, right? You're gonna be doing sort of the engine room work, right? Whether it's quality assurance, writing test cases, or fixing bugs in other people's code. The more simple activities that you start with at the sort of the basic level, and almost anybody in the world can be a coder. You pick up a book, you pick up a keyboard and a laptop, and you can write code. Anybody can. My daughter can do it. She's not interested in doing it, but she has to do it. And she doesn't even know what she's doing with some of her high school classes. There are lots of these little games that are available on, board games, which are literally coding, right? You're teaching the bug to move around, or you're making, you're trying to solve some problems. Hey, Cam, could you unmute yourself? The keyboard's making some noise.
Say again?
Could you mute your mic, please?
Yeah, sorry about that. Yeah, sorry. I'm always getting on them about that. Sure.
So so there's even if you're using Microsoft Word, Microsoft PowerPoint, all of their stuff, there's a level of programming that's going on, even if it's at the macro level, that people learn. If you could think clearly and you can kind of put together a set of steps to get from A to B, you can be a programmer, and that's everybody. But the the level up from being a coder to being what I call a developer is an interest in what's beyond yourself, right? Unless you're a one-man band, and there are people who could do this, right? You know, people who write apps for the iPhone and stuff like that. They're mostly one-man bands. But unless you're working by yourself, your code is going to fit into a much bigger structure. You know, think about the people who work on Microsoft Windows, or think about, you know, the kind of the massively distributed way that Linux is put together, or anything that's distributed out of an Apache license. You have to be able to understand what the people on the right and the left of you are doing, what the end users are doing, what all of this code is supposed to wind up building, and what is it building towards. One of the things that I think took Linux over the hump from being a hobbyist activity to being, you know, sort of a well-accepted part of the corporate world is the fact that the people who work on it, you know, the committers, they're committed, right? It's not just that they're committing code, they're committed to the success. And if you send them a bunch of crap, they're going to send it back to you and say, thank you, but no thanks, and please don't participate anymore. And so quality is more than just a measurement of does your stuff work, but is it readable? Is it extendable? Can other people pick it up and make changes to it, or use it as an example for something else? So it's not just how good is your code, it's how well is it commented, how well is it structured, you know, is it built to last, or is it built for, you know, is it built for tomorrow, right? You know, everybody does programming projects in high school and in college, and, you know, on the side. Think about the big concerns today, right? Think about a banking system today. 35 years ago, nobody cared about hacking, right? Nobody worried about somebody busting into the system and being able to deal with, you know, being able to go in and alter it. You know, I've dealt with, at IBM, I dealt with a problem where somebody actually was able to get in, mess around, and take, you know, the partial cents out of people's accounts. Nobody'd know, right? But this guy walked off with millions of dollars because he was grabbing the, you know, the eighth of a cent, or and if you've got 100,000, 200,000 customers, or 1 million customers, there's a lot of money to be found. So, you know, you've got to, you know, so there are lots of these, in the business we call them non-functional characteristics. Is your program securable? Is it securable in a consistent way? Do you allow for things like separation of duties, right? If you've got people who administer the product, and people who are users of the product, and people who are auditors of the product, can those features be separated? Right? These are things that separate a coder from a developer. And then finally, there's the idea of the architect. And everybody should aspire to be an architect. I was lucky enough to rise to the level to be the chief architect at CA Technologies, which is currently the largest ISV in the mainframe space, and a fairly sizable software company in its own right on the distributed side. And, you know, the hallmarks of an architect are not, are you concerned about the other pieces, but are you able to kind of take in the other pieces and understand how to build something bigger using the building blocks that you may not have coded? Can you basically abstract things that other people have done and be able to build upon them or extend them without having to go in and read every line of code and understand it to its fullest? And the only way to do that is to be able to communicate with people, to be able to read specifications, write specifications, ask the right questions. A lot of this is experience, but a lot of it is just personal curiosity and a commitment and a passion to doing the job. It's like anything else. You'll get good at it if you talk to other people who are good at it. You'll even get better at it if you talk to people who are lousy at it, because then you learn what not to do. And learning what not to do is a very critical thing. So, you know, so I went, you know, so I worked at IBM for 22 years. I could flip the camera up and show you my, you know, my 7 patents or 6 patents from IBM and the couple that I gotten from CA. I've done a lot of work, and almost every piece of work that I got a patent for, I worked with somebody else on, and I stood on the shoulders of other great people who patented work before me. Right? I don't know how much more I can emphasize that you have to be able to work with other people, and you have to be able to work with people that you don't like. You know, the IT world is full of people just like any other business. They tend to be a little bit more on the Asperger side than many other endeavors. But, you know, at the same time, you have to deal with salespeople, you have to deal with quality assurance people, you have to deal with your manager. Everybody's a little bit different. A I'll tell one story. I got roped into a project at IBM that Walmart, I was going to say a Fortune 1 company, demanded that IBM do something. I'll just say Walmart demanded that IBM make a change so that they could get rid of a competitive product. And so I was given 6 months to 9 months to make a huge change in the operating system to support this feature that Walmart needed. And they gave me sort of like five people who had never worked on any of this stuff before and said, go do it. And so I got a guy who was, he was at the end of his career. He was having microstrokes on almost a daily basis, which meant he was falling asleep at his desk. They gave me another guy who was bipolar and taking massive doses of medication. They gave me a woman, a very nice woman, named Mary, who had been in the business for 30 years and had never, she didn't finish high school and she didn't go to college. She was literally a retrained secretary, but she could write code. And I got a person out of the support area who wanted to learn how to write code, and me. And I got pieces of other people to get stuff done. And so it was a struggle, right? I mean, I had to not only learn how each one of these people worked, but I had to learn how to get them to work together. And to, because with 5 people, you could build a lot of code, but with 5 people running in different directions, you get nothing of any value. I literally one day had to take the guy who was having the microstrokes was having a conversation with the guy who was bipolar, and the guy who was bipolar drooled on the guy who was having microstrokes. He was leaning over him, both looking at the screen, like, doing this, and the guy drooled on him. And the guy who was having the microstrokes turned around and decked him. And now I got to figure out how next week to get these guys back together and continue to work with each other. So, adventures in programming, right? It's tough, right? As much as you want to be involved with the computer and getting your stuff done, it's really about getting other people to work. And that, sort of to take it to today, right? I left CA about, I guess 8 months ago now, mostly because they're really shutting down their mainframe business. You can look online at their annual reports, and you can see that they're just taking the investment way down and their sales are way down. I personally don't agree with their position. I mean, you can go and look at IBM and see, they're selling mainframes like they're going out of stock. Now, while it is true that the number of customers year to year on the mainframe side goes down, that's typically because the customers are merging, right? In the financial industries, you can't go a day without seeing 2 banks merge, or a financial services house buying an insurance company, or 2 insurance companies merging. It's we're still feeling the financial impacts of as the Europeans call it, the global financial crisis, and this is going to continue on. I mean, the banks in Europe have been consolidating. The banks in the Far East have been consolidating. There's certainly a fair amount of consolidation even between the continents, right? You got like Barclays has been buying banks up in South Africa and across the Middle East. So it's not that the amount of compute capacity is going down. It's that the number of unique customers are going down. The need hasn't changed, right? And we look at the number of hacking events that have occurred, and while it has not been recent that a mainframe's been hacked, mainframe credentials have been hacked as a result of these other activities. One of the 4-letter banks, and I won't say which one, had their mainframe breached, not because the software was hacked or the hardware.
Who, me?
But somebody had been able to sniff out mainframe credentials from the distributed side, and they got on and were able to wreak a little bit of havoc, but not too much, because the system was well locked down. So that sort of stuff is going to become much more interesting. If you want to follow a fun guy in the field, Wells Fargo has a red team that does security checking on the mainframe side, and the guy's Twitter handle is the Soldier of Fortran. Soldier of Fortran. You might want to follow him on Twitter. He's kind of an interesting guy, and he's always talking about security, hardware, people breaking into mainframes, how to break into mainframes. He actually posts what he finds. Sometimes, how to hack 3270, which nobody thought was, doable until he said, hey, look, it's quite easy. Depends on how your application's written. So there's a lot to do that there. I'm kind of jumping around here, but one of the reasons why I still think that mainframe is a good place to be, even though the overall number of customers is not growing, is the simple fact that if you look at server shipments on the distributed side, they're flattening out, and that's really because a lot of what used to be done on premise on distributed is now being done in the cloud, right? And to kind of step it back, one of the reasons why I felt that CA wasn't the place to be anymore is that they are trying to transform themselves into a development tooling shop, right? They bought products like Veracode, which helps do security checking, and BlazeMeter, which helps manage performance, and trying to think, Atomic, which is around workload management and DevOps, right? These things are becoming sort of part of the landscape in the Amazon cloud and the IBM cloud and the Google cloud, and more and more, the customers that I've been talking to, their major goals for the year are to reduce the number of distributed servers that they have to manage, because it's expensive, right? It tends to be a human being per 10 to 15 virtual servers. And I spoke to the head of infrastructure at one of the European banks late last year, so it's almost 12 months ago. He said that his goal for 2017 and 2018 was to remove 60,000 virtual servers and put them in Amazon. And what was the reason for that? One, they could reduce the number of people working on these things. Two, Amazon is more likely to get it right than they are when it comes to security and patching and keeping things up to date, because you think about a large European bank with 60,000 virtual servers, right? That's nothing compared to the millions and millions that Amazon is serving across the globe, and they have data integrity and data management that allows those servers to be maybe not instantaneously swapped, but if there's a local issue, they'll swap to a data center that might be across the country or across the globe, depending on what they need. Now, there's nobody really out there looking to kind of consume large mainframe environments. Even IBM is not up to that task. And the customers who have tried with IBM have not been all that successful and tend to take it back. So if you're looking at where the potential for a long-term career at a single place might be, it would either be, if you want to do it distributed, you better get a job at Amazon, you better get a job at Microsoft, right? You better get a job at if the IBM cloud survives, it doesn't, I'm kind of 50-50 on that. They seem to be late to the game. They seem to be much more feature rich, but they were late to the game, and Amazon and Microsoft seem to be doing pretty well. I'm having a conversation upcoming in a few weeks with a company that sells development tools, and they're trying to justify that I should pay them 5 to 6 figures a year for development tools, and I'm going to point them to the Amazon code commit page, right, which is $1 per user. Each one of those users gets 10 gigabytes, or 10. It's some massive amount of storage and some massive number of Git requests, right? So if I've got 25 developers, do I want to spend $5,000 a month on development software, or do I want to spend $25? I think I know what my answer is, right? And so that's a market that's not going to last. So I would when you take a look at where you want to go, do you want to work for a software development house? Do you want to work for mostly a consumer of IT resources? I would look at the places where there's going to be a lot of action are the financial institutions and the banks, right, and the insurance companies, because that stuff is always getting tougher. Security is always getting tighter. The regulations are getting tighter, and the thing about all of that legal activity is that it has to be written into code, and people are going to have to go back, unwind, in the mainframe case, now 50 years of code to be able to make sure those things go forward, and to be able, you have to do it in the light of, the Gartners of the world saying the mainframe is dead, and and then they turn around and say the mainframe is not so dead, and people who want to push this stuff to distributed platforms, and then they discover that it just can't be done, right? If you think about like the highest transaction systems in the world. One of the ones that I've had to deal with on a number of occasions is the Customs and Border Protection, the DHS, basically the passport swiping system. If you leave the country and come back in, they swipe your passport.
Uh-oh, I don't know what happened. Scott, you still with us?
Fees. And Oracle has been in there since 1992 trying to bust that off a mainframe, and they can't get it done. Right, and it's, you know, it's there is just architectural things about the mainframe that make it much more robust for certain kinds of activities. You know, I've talked to Visa, American Express, MasterCard, right? They've all tried and failed to move to distributed. That doesn't mean that the things in the kiosks are running directly on mainframes, and ATMs aren't running Windows or Linux in the background. But when the money hits where the money hits your wallet or the money goes into your bank account, that's all done on a mainframe, and that's unlikely to change in the next 30 years. There's just too much to unwind. There'd have to be some really tremendous technological change to allow for transaction capability to continue to grow at a rate that it does on the mainframe than on the distributed side. Nobody's been able to build anything like that. So I think I've hopped all over the place, Cam. Anything else you really want me to talk about?
Oh, you've done great, Scott. I mean, you've really done great. I expected this. I mean, in terms of looking at IT from a very philosophical point of view, with from a deep technical perspective. Yeah, I really appreciate that. I mean, we've had enough conversation to know that, you always look at this thing in something of a profound way. I like what you mentioned about architect, because that's kind of our program's product, if you will. We don't really train software engineers. Now, it's not that students from our program don't acquire software engineering roles, but we're just not a computer science department. We can teach you how to, like you said, we can teach you how to write code, right? But to be a software engineer, you got to get picked up by a CA or an IBM. They take a basic skill set and they make a software engineer out of you. But we do train architects. We do train architects, and a couple of people on here, particularly Kedrick, I see having a future as an architect. That's a great place to be. I think, and they've heard me say this, I think that architect is the best job in IT, and I think you would agree with me.
I've been one for 20 years, so I would say that definitely I agree with you there. But that's it's like that would be like trying to argue against my own personal beliefs.
Right.
But I think the unfortunate thing is that you don't start there, right? You have to get there, and you have to prove yourself to get there.
Exactly. Yeah. And it's all about the basics. I mean, what we're glossing over, and our program is really better than most, even computer science programs, in terms of taking a broad view of all the divergent technologies or the disparate technologies that make up IT. Now, where we're weak and where we're trying to get better is connecting those dots, because those dots have to be connected. But you have to have a fundamental skill set to start on a path toward being an architect. And nobody's gonna hire you as an architect coming in the door.
No.
Or at least they may give you the title, but it takes a while before you're actually an architect. But it's about the basics. And so those of you that came on late, it was my era, right? Completely my era. I moved too fast, and I sent all that information to the wrong class. So the one pager that you're going to have to write in the summary of this is recorded. I'll post the link after class, and then you review. And I think you only missed about 5 or 10 minutes, but you will be expected to have write up a recap of what we've discussed. So I'd like to open up, because I'm not going to keep Scott over. I'd like to open up to any questions that you guys have for him. I mean, you're looking at probably the top of the food chain in terms of mainframe architects. So go ahead, Scott. I'm sorry.
Yeah, so there's a real disconnect in the industry today that's economically driven. The work, what I would call the IT grunt work that's been going on, that goes on today, a lot of it has been shifted offshore. So sort of the entry level jobs that are easily filled by folks in India, folks in Eastern Europe, folks now in Malaysia and the Philippines. There's a lot of kind of body shop activity there. If you think that you're going to get into a company with sort of the skills that these places are selling, you're mistaken. You have to go and get the set of skills that they're not selling, right? And these companies like HCL or Wipro or Tata, right? They're not selling mainframe. They're not selling deep Linux. They're not selling COBOL. They're not selling PL1. They're selling J2EE. They're selling PHP, Python, right? Those things are important to know. But if you want to get in somewhere, latch on and move up, it's going to be very difficult if what you know is what these guys in these other countries know. I mean, that's, IBM has done that. CA is doing it, in droves. BMC is doing it. Microsoft has as many programmers in India as they have in Redmond, if not more. So you have to remember that if you want to get in and move up in these companies, you have to provide something that distinguishes you so that you can get the higher salary that you got to remember. These guys in India, I think that their full-time equivalent cost is under $35,000 a year, right? And here in the United States, $35,000 a year is, no programmer is going to work for that. So you have to have the skills that are going to justify somebody wanting to pay you 75, 80, 85, 90. So I just wanted to make that point.
No, thank you for that, and I hope you guys understand it. I teach mainframe, and I like the technology. I like technology because I like playing with it. It's very sophisticated. It's a deep pool, but it's not a religious argument for me. I'm not a Protestant trying to convert Catholics to Protestantism. You need a place to get in, and Scott and I have had candid conversations. We've had very candid conversations about this. All things being equal, GPA, internship, interview went well, etc. Student from A&T, student from NC State, both comp sci majors. In probably 8 or 9 cases out of 10, all things being equal, the student from NC State is going to get the job. And I'm not implying any racial connotations in there at all. Is that the perception is that their preparation is better than your preparation because we're in HBCU. We don't have anywhere near the resources NC State has. So you need an edge. And Scott made that argument even more so. You're a Java programmer, and you can be one of the best Java programmers in the country. Guess what? India's full of Java programmers. China's full of Java programmers. Malaysia's full of Java programmers. So you're going up against the world, and you need an edge. And mainframe gives you that edge. Now, what's happening to my students that have been in mainframe for a while? Now they're moving into other platforms, especially Linux. So they're moving from if you can do mainframe, you can move around. I'm not trying to say you got to do mainframe forever. That's not a bad place. Don't get me wrong. Mainframe is a great place to be, and it's not boring, and it's well paying, and it's interesting, and there's promotability. But you can go to other platforms. It doesn't tie you in, but you need an edge. I guess that's my point. You need an edge. I'll open up for questions now because I want to give you guys enough time to interact with Scott.
All right.
I'll call on somebody. We'll start with Ketry. He's a senior member of the team, so start with Ketry.
Okay, now I'm not well versed on mainframes, and I heard you talk about distributed service, and I guess they don't have the capability of doing transactions like mainframes. Why would that be?
Okay, so I can't. That would take that would be like a semester-long course. But let me put it to you this way: the underlying hardware architectures are very different. Now they both have concepts of CPUs and memory and all that, but the way mainframes do I/O is very different, and it's actually born out of the weaknesses of the technology in the 1960s and 1970s. So literally, in a mainframe, every I/O is managed by its own processor. So the ability to do a tremendous amount of moving of data in and out of memory is just, it's orders of magnitude different between a mainframe and a distributed system. And again, it's just an architectural difference that can't be overcome by software.
Somebody else? I'm going to call somebody. So jump in. This is your chance. Jump in. You got 3 or 4 seconds.
I think Kendrick's trying to say something.
Okay, you were basically meaning it's the way it reads and writes into memory or into the processor, right? That's what you're saying?
Yeah, there are many, many more paths into memory and many, many more paths out of memory. Okay.
Next.
Yeah, I have a question. If mainframe has been around for so long, in your opinion, why don't you think it has advanced as far as like technology wise? Why hasn't like been newer concepts of mainframe?
Okay. Well, so I think you're pointing out a common misconception. There's nothing that a distributed system can do that a mainframe can't. Right? You can run Python on a mainframe. You can run Java on a mainframe. You can run Linux on a mainframe, and you could run massive amounts of virtualization. People talk about running 10, 15, 20 virtual machines on a large Intel complex. You can run 30,000 on a large mainframe, right? And if you think about it, if I could run 30,000 or 40,000 Linuxes on a single mainframe, think about all of the I/O that I'm not doing because I'm moving data between the images through memory and not through, TCP/IP, right, which is much slower. So I think you're kind of reading into the what would you call it? The conventional wisdom that mainframes are old. They're not. The fastest single core processor today is still a mainframe. You can put 168 now in a single box, something like that, and they'll all work together, and they can all work together on a single problem, or you can carve them up and take those 168 and spread them out over 30,000 images, and they'll work they'll work that way. You can put ZOS and Linux in the same box and talk together. So I'm not, the one thing that I wouldn't do with the mainframe is I wouldn't use it to push a mouse around the screen, right? Just because the relative cost is there. But, at the end of the day, right, are you going to take a piano and load it into a Volkswagen, right? Or are you going to take a Mack truck and use it to take, your family out to dinner, right? You use the right tool for the right job.
Yeah, exactly. Yeah. I've got a question from from Chad Thomas. So in the scope of web development, Chad Thomas is an aspiring web developer.
Okay.
What is the most important language framework library to learn, in your opinion?
So here's my opinion. It doesn't freaking matter because next year it's going to be a different one.
Yeah, no, yeah, I agree. Yeah. But go ahead, Scott. I'm sorry.
I'm just saying. So what you need to do, if what you want is to get a job this year, you got to do whatever's hot, right? I don't even know what's hot this year, but if you look at it, even I could see this on the internet, right? Things are beginning to converge, right? Even I'd be willing to bet that the software that's behind the American Airlines website, that's behind the British Airlines website, that's behind the Delta Airlines website, that's behind the KLM website, and they're all different companies, is basically the same stuff, right? So what you need to do is you need to investigate, if I'm going to go work at American Airlines, go figure out what that stuff is, right? You can actually look at it, right? You can pull down the web page and tear it apart and go look at what it is. And that'll be different, for American Airlines versus Citigroup versus Wells Fargo, right? Because they'll and for the most part they're gonna say what they want in their job descriptions. You'll see it over and over again. C++, Python, Perl, right? PHP. It's the same nonsense. But then there's because a lot of that stuff, it moves so fast, but there are these stops along the way, right? And those stops are what like PHP is just not going away, right? It's just not going to because there's so much written in it. Right, Java's not going to go away because there's so much written to it. JavaScript has so much written in it, so there's it's not going to go away. And there's other stuff that's kind of flash in the pan, and moves on. right?
Yeah, yeah. And I would add also to that, and thank you for that, but I would add also, learn the fundamental, the underlying stuff that changes very slowly, as Scott said. Like PHP is going to be there. So PHP is a language that you want to learn. Learn the basics of how the web is constructed. Basic HTML. I mean, you guys find HTML kind of easy, but that's fine. But understand that that's a fundamental. And XML. Now, you guys really need to learn XML, because XML, and we don't talk about XML in almost any of our programs. XML really is the way data is described, right, and defined today. So you need to understand the basic XML. But I agree with Scott. I mean, the top layers, the cosmetic stuff changes. If you understand the underlying principles of that cosmetic stuff, then you can adapt. You can learn whatever's new in a couple of hours on YouTube, right? So yeah. That's
when I went to work as a college student in the financial area, I was working at PL1. I'd never written a PL1 program in my life, but I had taken Pascal in high school, and it was close enough that I could go. I went to the bookstore, and I found a business programming in PL1. It was a 200-page book. Took it back to my dorm room, opened it up, looked at the program that was in front of me. Voila, I was a PL1 programmer. That was it.
But I agree. I mean, you shouldn't leave any IS or comp sci program or IT program, and many students do. I'm saying this because many students do, without knowing what an if statement is, how loops work, variable assignment, arrays, some basics of data structure. You should not leave these programs, because that will equip you to adapt to whatever comes along. Now, my job is to tell you what those things are. And I validate what those things are by continuous conversation with people like Scott and people at that skill level. What's important, what's not important. One of the reasons that you have more RDZ in our program is because the hiring managers say that I don't need to spend time on it. They need to learn ISPF. That's what they need to learn. Now, I know that not because I just figured it out. I asked them. So if you know ISPF, whatever that GUI that comes along is going to be, it doesn't matter what it is. You will know how to talk to that GUI, because it's going to have to talk to TSO somehow. And if you understand ISPF, you know how to basically communicate with TSO. And it's my job to set that mark, that path for you. That's my job. But great answer. I think we have time for one more question. We got to let Scott go. Anybody?
Yeah, I got a question.
Sure.
So, for example, someone like me who's all of us are going to graduate within the next year or so. Can someone like me come out of college and go straight into mainframe, or in your opinion, do you have to build your way up to knowing mainframe and getting a top level position like how you are in right now?
Well, so what I've seen, and I've certainly looked at, I've looked at companies like JP Morgan Chase, Citigroup, Fidelity. They all have gaps, right? There's a lot of people at the top end, right? I mean, I'm at the very end of the top end in terms of age. I'm 53, right? Almost everybody in this business is older than me, right? So there's a lot of opportunity at the entry level, and there are companies like that, the large banks, large financials, insurance companies. The parts of the world that are run by mainframes, they're dying for people who just want to come in and learn, right? So if you can demonstrate basic competency around IT and a willingness to learn, and you have to be sociable, right? One of the other jokes I think I probably told Cam this one is, what's the difference between an introverted IT person and an extroverted IT person? Well, an extroverted IT person looks at the other person's shoes. All right, Cameron like that. The point here is, if you can the part of being able to demonstrate that you can learn is that you can communicate with people, listen to them, ask questions, and not make the same mistake twice, right? that they'll take you, right? If you can go in there and say, hey, you know what? I'm in the upper third of my class, upper quarter of my class. I really want to work on mainframes. These are the skills I have, right? They know you're not going to come out of school being a COBOL whiz. They know you're not going to come out of school knowing all the ins and outs of doing systems programming on MVS or COS. If you demonstrate that you want to learn, they'll be good with it. And, they'll probably start 5-10 grand higher than most of the other areas of IT.
Oh, it's more than that now. We got people started in the 90s now. We've crossed over to the 90s. And we're still putting putting people in generic IT slots in the 50s. So now, now everybody in mainframe, every other non-mainframe IT job doesn't pay in the 50s. They pay in the 70s and 80s also. But mainframe people usually start at least 10 grand, in my experience, than everybody else. And so I will also say that in my class, what we do is we teach you the basics. If you don't have an anemic GPA, if you've got it, and that's why I tell people, do our program. Don't sleepwalk through these classes. Pay attention to the database class. Pay attention to the networking class. Understand that stuff. Don't just try to pass a test to get an A on your transcript. That's important, but you got to leave there kind of having a fundamental understanding. If you have that when you come to my class and I teach you about JCL, ISPF, and you don't bomb on the interview, there's a place for you. So it's not that complicated, but you got to do your part. Scott, man, always a pleasure. I don't know. Are you going to do you still go to the Z councils in Jersey City?
No.
Yeah. Well, I guess I won't see you till Sacramento then. You'll be is 21st Century sending you to share also?
Yeah, I was at the last year. I'll probably be at the next one.
Yeah, so I'll be there. But I want to thank you. And it's been really, you guys really don't know kind of the knowledge and the wisdom that he's imparted to you, but you will. When you get out there, you'll see the difference between having these conversations before you graduate and not having.
Yep.
Yeah. I want to thank you, Scott. And take it easy. Yeah.
Go ahead. Please want to link in with me on LinkedIn, and they can fire me questions at any time on there. I can certainly, you can say, hey, what about this company? I'll tell you what I know. Because I've dealt with every large bank. I've been captured and put in a basement of almost every large bank in the world during an IT crisis. So, I can kind of say, hey, you know what, this bank might be better to work at than that bank. And here, these guys are doing this and those guys are doing that. So feel free, just reach out.
I really appreciate it. And I'm expecting you guys right up. I'm not going to make it due to after Thanksgiving, so you got some time. But I'll post a link to the recording for the parts of that you missed. But I really want you guys to capture in the Cisco one. I don't know when I made it due, but we got to have the Cisco one also. But I really want you guys to take away the nuggets of these conversations. I'll see you guys on campus.
Thank you.
Bye, everybody. Yeah. Bye, Scott. Thanks.